All right, question 8. A cylindrical boiler with an open top is to be built from stainless steel with a copper bottom. The price of copper is 5 times the cost of stainless steel. Determine the most economical dimensions of the boiler. If the volume is 5 pi meters squared. Okay, that's an important little bit of information there. Okay, so we already know that last little bit of information is telling us that the volume of this thing and the volume, okay, of a cylindrical boiler. Okay, the volume of a cylinder is going to be pi r squared times height, but we already know that this is 5 pi. So that's significant because that allows me to cancel out the pi's here, and I have a nice relationship between r and h here. And in fact, when I look at that, I suspect that I'm going to have to do a substitution in a bit here, and to avoid throwing in square roots, I'm going to isolate for h. H is equal to 5 over r squared. Now, I want to determine the most economical dimensions, which means I want to minimize cost. So how much does this thing cost? Well, we're making the sides out of stainless steel. The area along the side of our cylinder here is going to be 2 pi r h. But I'm also going to throw k in here because the truth is I don't know how much stainless steel costs per meter. So we're just going to let k equal the cost of stainless steel kind of per meter squared. Okay, now bear in mind, I probably should have drawn this out to begin with here, but I've got my cylinder here, this is my radius, this is my height. Okay, I'm kind of assuming that people are seeing that here, but so that's the cost of the base here. The bottom, okay, the area of the bottom is pi r squared, but it costs 5 times more than stainless steel. So there's this added factor of 5k there. Now I am going to take the derivative of this in a moment. Remember, k is a constant here, but r and h are both variables, and I do have this means of replacing the h here. So this is going to be, the cost is going to be 2 pi r 5 over r squared times k plus 5k pi r squared. We'll just put the variable at the back here. So my cost is going to end up being, when I simplify this, 10 pi k over r plus 5k pi r squared. Now I've got cost in terms of just that single variable r. Again, remember, k is a constant. So the derivative of this will be, in terms of r, will be negative 10 pi k over r squared plus 10 k pi r. And seeing as this is the thing that I want to maximize, I'm going to set that equal to 0. I will maybe bring the negative term over, so this becomes 10k pi r is equal to 10 k pi over r squared. And then look what cancels here. So much cancels, and I'm left with r equals 1 over r squared, or r cubed equals 1, which means r is equal to 1. So it turns out the radius has just got a unit of 1 here. Now if that's true, I just come back up to here to find out what my height is, and so now I can conclude that the radius is equal to 1 and the height is equal to 5.